Alright, so we should be live. I have not really spent much time getting the machine set up because I'm worried about clouds. I just wanted to get it out there as soon as possible, so I'm now going to start fiddling and try to get the best image I possibly can. Okay, so I don't know if anybody's there, but I am currently working on trying to get the image as best as possible, so just hang around and I will do a little explanation of what's going on as soon as I can try to make it a little better. Okay, so I think I'm ready to do this. Hey, Farouk. Yeah, okay, so I guess I had a better mic, but I think that the better mic is not going to work. I don't know about the quality of the streaming because I'm doing this wirelessly on my cell phone, so the cell phone network is taking the burden of the broadband. So I don't know exactly what the streaming quality will be. I'm going to work a little bit and trying to clean it up a little bit, but anyway, so that's why you're seeing what you're seeing and why you're hearing what you're hearing is because I'm in the, I'm in the middle of a graveyard basically, which is the nicest place I could find to do this live stream. So what you're looking at is a grand conjunction of Jupiter and Saturn. The brighter one is Jupiter. That's the one in the upper, at the top of the image there with the smaller bright dots around it. Those are the moons of Jupiter. So the Jupiter is the brighter one, and Saturn is the elongated one below that. So what we're seeing two giant planets, the two biggest planets in the solar system, as they travel around the sun. They travel in a big disk, right? They travel in basically a plane as they go around the sun. So every so often, they are next to each other from our line of sight. So we look and we happen to see Jupiter and Saturn along the same line of sight. That's called a conjunction. You can have conjunctions of other planets, not just between Jupiter and Saturn. All the planets go move along the same plane, so you can have conjunctions of other planets. This is called a great conjunction because it's when the two of the largest planets in the solar system are along a line like this. So the first thing to remember is Saturn is much further away from the sun than Jupiter is. That's still true. They look extremely close in the sky. This is only about 1/10 of a degree. In fact, if you don't know what I'm looking at, I would recommend just going outside your house right now and looking south. You'll see one really bright dot and one small dot right off to the right, upper right of it. That's Jupiter and Saturn. That's what I'm showing you zoomed up in a telescope eyepiece. So that's what's happening with the conjunction. This occasional thing where the planets line up happens every 20 years or so. This one, the planets are almost on the same plane of the solar system, but not quite. They're tilted a little bit this way and that. And so every conjunction is a little bit different. And so this one is very, very close. The planets are within 1/10 of a degree of each other. That is a super unusual event. The last time the planets were this close was over 800 years ago. So that's actually what makes me excited about this event. They happen every 20 years, just general conjunctions. But this one, you can look at the giant planets in the solar system through the exact same telescope eyepiece, and I can show you the view that I'm looking at right now. This is the real planets. So let's talk a little bit about the planets. So the lower one, Saturn, you can see it's elongated, right? It's not a single circular blob like you would expect a planet to be. That's, of course, because Saturn has rings. Now, unfortunately, my phone is not quite sensitive enough to pick up the rings. If you look at Saturn, you can see it wobbling back and forth. I'm looking through, if you go outside and you look at this event, it's very low on the horizon, so there's a lot of atmosphere between the telescope and the planet. So the atmosphere is moving back and forth and making the image sort of distorted. There's nothing I can do about that. So that's partly why it's kind of moving back and forth. But if you look, you might be able to occasionally glimpse that Saturn has a blob surrounded by rings. It might be kind of hard to see, but you should be able to see that if you can. So that's about Saturn. I think I can move a little bit. Occasionally you can see moons around Saturn. We may not. No, it does not look like we're lucky enough tonight. So if you look, you might be able to see another very, very dim, bright dot nearby Saturn. That would be Saturn's moon Titan. Titan is an awesome moon. It's the only moon in the solar system with an atmosphere. It's very, very exciting. But I think that tonight we're probably not going to get that. Ooh, you can see that my telescope is drifting. That is exciting and not enjoyable. But you can see around Jupiter 4 smaller dots. Those are Jupiter's moons. And I believe the order going from left to right is Ganymede, Io, Callisto, Europa. Jupiter's moons orbit around Jupiter with a relatively short period, right? I mean, I think Io orbits in a matter of days. And so actually at any given moment when you look at Jupiter, you're going to see a different ordering of the moons of Jupiter. Just like our moon takes 28 days to go around the Earth, the moons of Jupiter take some period of time to move around Jupiter. Historically, of course, that was really important. Those are called the Galilean moons. Those 4 moons, those are the 4 moons that Galileo saw through his telescope, and that basically convinced Galileo that the heliocentric model of the solar system must be correct, because, okay, there's things orbiting around Jupiter. That means not everything orbits around the same point in the solar system. That was what they were thinking, was that Earth was the center of the solar system. Galileo observing this phenomenon of the moons going around Jupiter is one of the major reasons that the heliocentric model of the solar system became popular, and is what, of course, we know is true today. So that's a historically important aspect of looking at. Whenever you look at Jupiter, you have to remember that's what happened. Galileo basically took the very first telescope and made that significant, important scientific discovery. So the moons of Jupiter are super interesting. Ganymede is the largest moon in the entire solar system, and Callisto. So Ganymede and Callisto are two large moons. They're the one that's very closest to Jupiter, and I think the one that's furthest away. They're sort of icy, rocky snowballs. Ganymede is further away. Ganymede is further away than Callisto, but they're just sort of like giant icy snowballs. The other two moons, Io and Europa, are quite interesting themselves. So Io is the one that I think is on the left-hand side in the middle. So Io is the moon that is closest to Jupiter, and Io is a moon of volcanoes, sulfur, lava, just basically chaos. So what's happening is Io is orbiting so close to this massive planet Jupiter that it's being stretched and squished and pushed around in all these different ways, and it's heating the inside of Io, and there's lava basically being exploding out of the center of Io because it's so hot on the inside because of this tidal heating that Jupiter is doing on it. So Io is a very interesting moon. There's some fantastic pictures from Voyager. If you would just want to Google that, check that out. Europa is another super interesting moon. So that's on the right-hand side of Jupiter, is I think where Io is. Io is basically has a giant underground ocean. We think the entire surface of Io is basically covered with this massive, and an ocean which is like kilometers, maybe dozens or hundreds of kilometers deep, extremely deep ocean with ice all around the outside. So it's basically an enclosed ocean. It's a primary place in the solar system where scientists believe we should be looking for life, and indeed there are spaceships out there. Actually, I think not currently, but there are plans to go to Io and look for life. It's one of the major places in the solar system where we believe we should look for the presence of life. So I'm just going to go back over to the chat. And sorry, I just want to resize my window a little bit so I can see what's happening. Okay, so if you're just joining, I think I'll just go real quickly over. Please, if you have any questions, put them in the chat. I don't know how many people are going to be on the stream tonight. It's not great weather. It's freezing out here. So if you have any questions, just throw them in the chat, please. I'll say the same thing about what conjunction is, and then I'll try to mess around with the image a little bit. So again, we're looking at the grand conjunction between Jupiter and Saturn, the two giant gaseous planets in our solar system. They are closer today than they have been in 800 years. Essentially, it's a coincidence because the planets rotate in the same plane. They will occasionally be along the same line of sight, and that's what we're looking at tonight, is that occasional coincidence of the planets being along the same line of sight. There's other interesting things about conjunctions, the grand conjunction is Jupiter and Saturn. There's other minor conjunctions, say between, in about 4 years, there'll be a Mars-Jupiter conjunction. What's interesting about the last one, which was in about 2000, because these things happen every 20 years, almost all the planets were in the same region of the sky. So it wasn't really a conjunction between Jupiter and Saturn. It was Jupiter, Saturn, Mars, Venus, and Uranus, and they weren't as close as they are in this image. Of course, Jupiter and Saturn haven't been this close in 800 years, but they were all in the same sort of generic region of the sky. So I was just sort of investigating the other conjunctions that have happened in my lifetime and came across that one, which was a pretty interesting one. Of course, all the planets being sort of in the same place. So I'm going to play around with the image a little bit, see if I can see. I can see Saturn's rings is the tricky part on my phone, but it's not being transmitted through the stream very well. I mean, I can also zoom in. Oh dear, they're gone. Okay, one moment. Oh, it's clouds. It's clouds. Sorry guys, I can't see them either. So I think we'll just take a moment. I'm gonna just hang out. It's really getting quite cloudy at the moment. You know what? Let me look at something else. We could look at Mars, because Mars is up. But let me just swing over to the moon, and we can see if we can check out the moon tonight. So while we're slewing, let me just mention what I'm trying to do, the technology I'm using here. So I have my phone attached to the telescope, which is attached to a laptop. They are both connected to the broadband service I have on my phone, Google Fi. The laptop is running a bunch of open source software. It's a Linux machine. I'm running OBS Studio. I'm using something called Screen Copy to grab the image of my phone and put it on the screen. Then I'm streaming via YouTube. So lots of this is not like super high technology, but it is sort of interesting that this is something that would have basically been impossible 10 years ago. And this phone also has an astrophotography mode, which is also a unique feature of these Pixel phones, which make them really nice for astrophotography. So you can see that I'm looking at the moon, but it's totally saturated. I think I can fix that if you give me a moment. Yeah, there we go. Looking at the moon through a telescope is one of the most awesome things in the world. So you can see what I'm doing is I'm looking right at the terminator between the bright side and the dark side of the moon, and you can see some really interesting features. Like you can actually see, sorry, it's drifting. One of the problems with these kind of nights where it's cloudy, the telescope is computerized, and so I told it beforehand where a bunch of stars were and said, okay, based on these positions of these stars, go find Jupiter. When it's cloudy and I can only use a few stars, the telescope doesn't align very well, and so I can't really, I can't really point it very accurately. So that's part of what's going on here a little bit. So, yeah, I see somebody wants to see zoom in on the planets and see Saturn's rings. Once it comes back out, that's exactly what I'm going to do. But it is still currently cloudy for me. So anyway, so one of the cool things when you're looking at the terminator, that's the line between the dark side and the light side of the moon. Sorry, I shouldn't say dark side, right? Not the dark side of the moon, like the back side of the moon that faces away from the Earth, but the dark side in the part that the sunlight is not falling on, right? So when we see the shade on the moon, that's the shade that the moon, that the sun can't reach. The part that's light is the part that the sun is shining on. So when you look at the terminator here, what's really interesting is you can see the craters, obviously, right? But you can also see the shadows inside the craters, and you can actually sort of tell which craters are deeper and which craters are more shallow by looking at the depth of the shadow. And I mean, you can even see in the middle of the image there, sort of off to the left, there's those three sort of dots. That's like the peak of the crater just barely coming up, and the sunlight is just barely hitting the top of it. So that's really interesting. It does look like the planets came back out. But of course, because of the pointing, I don't actually know that if I go back over there, if it will be dead on Jupiter and Saturn, or I'll have to do some manipulation. So this is the very edge of the moon. You can see this is the actual edge. So you're looking at both the shadow from the sun and actually passing into the other side. That's where the other side actually is the dark side of the moon, the part that doesn't, that we don't see from Earth. It is oversaturated a little bit. My phone's having trouble compensating. Sort of a weird color, but sort of shows you some of the other features. Okay, it looks like I might get the Jupiter and Saturn for another 15 minutes maybe before they go behind the trees, so let's try to do that. Sorry guys, hold on. I am just getting some hand warmers because it is freezing out here. Okay, so you can't see anything, and of course that's because I can't see anything either, and as I was slewing, Jupiter and Saturn went behind the clouds again. Okay, well that's wonderful, so let's try one more thing, and let's try to jump over to Mars, since the clouds are trying to mess with us. Actually, the telescope is trolling me and is going the long way around. So I'm actually going to just step around the telescope, carrying my laptop. This is why you don't do this. Still cloudy at Jupiter. Just caught it. So let's see if we can do better. Yep. Okay, so that is Mars. Now it does not look overly impressive. That's indeed because Mars does not look so impressive. I see Farouk's out of here. Thanks for joining, Farouk. I hope you and your son enjoyed it. Just trying to do it for anybody who's interested. So what we're looking at now is Mars, and you can see that Mars isn't very interesting. You can see that it has some real size. It's not a star. You can actually see the physical size of Mars. It's not red. It's actually red in the sky. Like if you looked at Mars with your eyes, it would look red. The lack of red is just the white balance of my phone making it not look red. I might be able to play with the instruments a little bit to try to give it its actual real red color. So Mars is actually relatively close to the Earth now. Sometime in August, I think it was at the closest that it gets to, and actually you could see its size was pretty large at that point. Mars has moons. It has two very, very small moons, but they are too dim for us to see. And typically this is what you see when you look at Mars through the telescope, is you just see something that looks kind of like a blob that may or may not be kind of red. Let me see if I can try to get some red happening. Oh, there you go. That was pretty easy. So that's like a natural white balance. So that's about the color that you see. That's actually funny. So on the stream, it doesn't look red to me. On my phone, it actually does look red. So maybe the stream is doing something a little bit strange to the color. And I can just see Jupiter and Saturn coming out again. So I'm going to make one more attempt to go back over there. And then I might need to just call it a day, because if it's cloudy, it just is cloudy. Actually, I can see they are almost in the trees now. I don't see anything. Let's see what we can do about that. Oh, there's something. Yeah. Yeah, so there they are. Get the sensitivity up. Okay, so now since I basically covered, you can't see the moons of Jupiter anymore. That might be because we're looking through too many clouds. I think since I have the opportunity, what I'm going to try to do is try to show you the rings of Saturn by going to a different eyepiece. This will take a moment to get set up, but we might as well try it. Again, if anybody has any questions about any of this, just drop them in the chat and I will try to answer. Oh, they're disappearing again. They are disappearing again. Nope, that's it. I think that is it for Jupiter and Saturn. They went behind the trees from my perspective. So just from my viewing location, I cannot see them anymore. I can just get them peeking through the trees, but there's no way that I'm going to get them on a telescope. So I think, I'll probably end in a few minutes. I think. Yeah, I see there are a few people still on the stream. So let me just finish up by going back to the moon, because the moon is super bright and is high in the sky, so it's not behind any trees. And I'll just spend a few minutes sort of zooming around on the moon, because the moon is super cool after all. Actually, that's pretty cool. You can see as the clouds pass over the surface of the moon between us and the moon. Yeah, it looks like we might be having some technical issues. I'm not sure what that's about. Hold on for a moment and I'll see what I can fix. Okay, so I think I've reconnected now. I'm not sure what that was. Like I said, I'm doing this off of the cell network, so whatever the cell network kind of wants to do is what is going to happen to us. So let's just sort of zoom around the moon a little bit. Let's see if I can get the focus better. There we go. Of course, probably you're seeing a lower definition image than I'm seeing, so I'm super impressed by what I'm seeing on my phone, and you might be less impressed by what you're seeing through YouTube. I don't really know. Let's look around. You can see a nice, cute little chain of craters right there. Oh, there's some mare. So there, I can talk about the regions of the moon. So basically, the moon has two essential regions: the highlands and the mare. The highlands are the lighter regions. They actually are generally higher than the mare. The mare is a result of old lava flows. So typically, the moon's surface looked basically like the highlands for for most of its life, most of its history, but then it got bombarded, particularly early in the history of the solar system, up until several billions of years ago. Those bombardments created craters, and the moon used to be an active place with a liquid interior, a liquid magma interior, and so when the asteroids would punch through the surface of the moon, the magma from the inside would leak out and fill up the craters that the original asteroids made. And so when you see these regions of dark mare on the moon, that's what you're looking at, is the magma that came up and filled the craters and then solidified into what we see here. And you can also do sort of interesting things if I just zoom in a little bit on that location. You can see that there's some highlands in the lower part of the image and on the upper part too. Most of this region is mare, but you can see that right in the middle there's a crater. And so the mare regions are generally younger regions, right? Because they're basically highlands destroyed by impactors. And when the lava comes up and fills in the craters, that creates younger regions, right? The highlands had crater impacts, but they're the original surface of the moon, not the younger surface created by the mare. But there's a crater right on top of the mare, right? So this is probably like some kind of reasonably old mare region. Actually, I think we're looking at Mare Tranquilla, which is the dominant area of mare on the moon that you can see with your naked eye. I'm actually not that good at lunar geography, so I don't know that that's the part of the moon we're looking at, but I believe that's basically it. So before I get out of here, let's just scan around the moon a little bit. Yeah, you can kind of see when you look at those obtuse angles, when you're looking down at the lower part of the moon, you can sort of see into the craters. There's some craters on that lower part that you're sort of looking over the top of. That's kind of interesting. And the clouds passing over. Oh yeah, actually I really like this. I already mentioned this, but I really like the idea of like seeing the peaks of the craters coming out of the shadow of the moon. Like you can imagine if you were there looking at that would look very dramatic, because you would see this entirely dark surface with just these like little itty bitty peaks of light of the tops of those craters peeking out over the shadow of the moon. Yeah, like those two little guys right there. That's really interesting. All right, well, I think I'm going to call it, guys. Let me know if you have any final questions, but I tried my best to show you the grand conjunction of Jupiter and Saturn, and then I spent a little bit of time after the planets set below the horizon looking at the moon as well. The planets are going to be close to each other for the next few days, so if you did not personally get to see, like with your eyes, the two planets and how close they were, they're going to be close for the next week or so. It's going to be sort of interesting to see that. So make sure that if you get another clear night, hopefully a nicer night than we had tonight, make sure just to go out there and take a look, because it's a astronomically interesting event and something that we probably won't see. We won't see for another 20 years, and maybe something like that distance between the planets won't happen in our lifetime ever. All right, great. That's it. This is Chris Dustin from the Merrimack Observatory. Thank you for watching. Hope everyone has a good holidays and is staying safe out there. All right, later, guys.